for the delay. Uh, Alright, I hope that my laptop is going fine for today. I already not sleep for a few days trying to find out what is the problem. Actually, the problem is the battery of my laptop, right? It's already, we call it, the life is already expired. Okay, so what happened is I need to do some experiment on my thinnest laptop in the world. Open it and then change to a new battery. Now I think it worked fine. Okay, guys, how are you? So tomorrow you will have, some of you will have the test 2 for instrumentation, right? Yeah, okay. I'm also preparing the question. I'm not yet doing that question. So what the kind of question that you want? Medium, uh, well done, or rare? Rare, medium, well done. Right. Okay. All right. That's mean the type of question that never asked, never been asked before, right? Okay. For today class, so what I promised to you, so we're going to do some revision about the test 1, right? So the test 1, sorry, the test 2, sorry about it. The test 2, your test 2 on your, in this Sunday, right? And what is it? What did I mention it to you? Okay, yeah, stability and root locus. Interpretation of root locus, right? So normally this, actually this topic that you will interpret what is the value of the k, right, at the certain roots that you got it and so on. So normally this chapter will be covered on the last chapter, on chapter 6. And normally others lecturer, they don't teach this chapter yet. So I think for the test 2 you will focus on the stability and also the root locus, and then you need to be able to remember and know about the frequency analysis, and until the block diagram in the series, right? Sorry, until the frequency analysis in the series. Okay, so this one, all right. So I have shown you a few things or how to do it quickly, right? Using the calculator and so on. So for today, I hope that we can do some revision about it, all right? However, for the root locus, right? So I will go through our next topic lah. That's mean, sorry, we go through the last topic, the chapter 6, this one, because this one will implements the root locus also. So at the same time, we can do some revision lah. Okay, about this one. Is it okay? We can go to for this chapter, chapter 6. Boleh, eh? Okay. Right. Can I start the class now? Boleh?
Boleh.
Okay, boleh, eh? Tak apa dengar kejap. Bukan suara sikit. Okay. Alright. So this is the chapter 6. What we have been discussed a little bit, I think about 5 minutes. So maybe I can go through again. So for the control action, right? So this is the parameter that we going to control. Steady state error, of course. The overshoot, of course. The rise time, normally is depending lah. If your system that you require very fast output, all right. So maybe you can control the rise time. The more important thing is the settling time. So how fast your output can achieve the desired output that you want lah. For example, your air conditioning, you set it at 20 degree. So and then you turn on your air conditioning. So how long it will take for 20 degree? So that's why we look at the settling time. For the basic of a control system, so you will have the controller process. The process that's mean involving the mechanical part like air conditioning, like the circuit and also the compressor and so on. So that's it, the process. The controller, that's mean you have the remote, right? So your remote set it, the fan number 1, fan number 2, fan number 3, right? If you set the fan number 3, so that's mean it will tell the process, that's mean your compressor, it will speed it faster than before. Okay, that's one. Okay, so for the basic one, when you implement the PID, right, at your controller, so it consists, this is GC, that's mean gain for the controller, it consists of KP plus KDS plus KI plus S. So this one, what is mean, this is P, this is I, and this is T. Actually PID, right? PID lah actually, right? So normally we call it PID, it's not PDI. Okay, all right. So what is P? P, that's mean proportional. Okay, so where your GC equal to KP, right? Okay, you can look at the question here. Integral I, so is based on this formula. All right, so where the GC equal to KI over S. All right, actually there are some calculation how can you get this one. All right, so maybe I can show a little bit about this one lah. Okay, so you got it, the M KI ET dt here. So when you convert into Laplace, okay, you Laplace it. So this one you got it is MS KI, and then you Laplace this one dt. So MS here, and then KI. So when you Laplace the ET, if you remember back, so we got it is ES over S here. Actually, we can use the capital lah, alright? Because when you Laplace, the symbol will be changed, the capital one. Okay, and then what you got it here is KI over S. You time with ES. Okay, so this one is MS. Okay. And then MS divided with ES here, then you got it KI over S. So MS or KS over ES here, this one we call it is GCS. Okay, KI over S. So that's why the formula it will be like this one. Okay, KI over S. Okay. So in this note, I don't show the detail lah. Alright. And so what you need to do is only when we call it a KP, proportional, right? So it's KP. Integral is KI over S. The good thing about when you implement the I, right? So you can eliminate the error, right? For example, for the class 0, you can eliminate it. Because we want to achieve the steady state error, right? So that we can get it 0. And D is given GC equal to KDS. Okay. For the derivative that you cannot eliminate the steady state error. Okay, I will show you the graph so that you can look into that. Okay, and sometimes we combined it between proportional and integral. We call it PI. So the controller that you can use is KP plus KI over S because you combine between P and I. Okay, Then of course, if you want to make it simple, so you can just set a KP, and this one is TI. TI is what? Is KP over KI. So when you do in your MATLAB, so you can play around with these two variables, KP and TI here. Okay, right? Some of them we combine between proportional and derivative. So derivative is can minimize the what we call it overshoot. I will show you later. And then the formula will be like this one, KP plus KDS. And then to make it simple, so KD over KP here, you can make it a TD so that you can just adjust only two variable, right? This one. And we also can combine P in I and D, all right? We call it PID, okay? So a combination between KP, KDS, and KION. And normally, how to change all this value? So we can change it manually. We can change it manually. For example, you can put it KP, KI, KD, KT is 100, KI is 10, KD is 2, okay? And then you can get it the steady state error, right? And then you can get it the overshoot, for example, and then you can get it the settling time, right? And then you adjust again 0, 100 and 10 and 1. What is it? So it is quite difficult to adjust it manually, right? But to understand the concept, yes, you can do it, right? But normally we using the method, we call it the Ziegler-Nichols method lah, right? Where you use the MATLAB, so you call this method, right? And then if we do the what we call it, the this value, if we do by automatically, right? And it depending on our requirement lah. If we want to get the steady state error almost 0, the settling time that can be accept like less than what we call it 2 seconds, for example. So we can use this method. However, we not cover lah in this class. Okay. I like to show you this one so that you can get it. What is purpose of using KP, KI, and KD? Okay. Whether I can zoom in on that. Display setting, duplicate. Okay, yeah, I can show you. Oh. Okay, boleh nampak kan? Boleh tak nampak? Nampak
Nampak tu.
Nampak tu.
Okay, good. Right. Alright, let's say you have this control system like here. So this is your process, right? And this is your controller, right? And this is your feedback lah. Okay, and output and input. Let's say we implement only KP. Okay, KP. So when you set the KP equal to 1, you will see this kind of graph. Okay. When you set the KP equal to 100, the red color is your input, right? The step input, because it is quite easy to study only the step input. You will see that, yeah, KP equal to 100, yep, the rise time it will be a little bit slower, right? And the error, the steady state error will be a little bit large lah. Okay, this one. How about the settling time? Yep, it will be longer lah. Okay, and you put it again, KP equal to 300. Okay, this is what you doing it by manually, right? You will see that, yeah, KP equal to 300. Yep, the steady state error will be decreased. Okay, but it will have some overshoot here. Okay, and how about you adjust KP equal to 600? You will see that, wow, the overshoot will be increased. Okay, and the steady state error, yep, you can minimize a little bit the steady state error, but you cannot get a 0 steady state error. Okay, so it's depending on your requirement. If you want to accept, it's only the rise time, the what I call it, the fast settling time, right? And maybe the error that you can accept plus minus 2 degree, for example, for the what you call it, temperature. Yep, you can only adjust the KP. Okay, this is the purpose, right, or function of when you adjust the KP. You will see that rise time it will decrease, like you see, like this one. Okay, this rise time, okay, compared to this one. Yep, it will be this one will be more faster than this one. But overshoot, it will increase the overshoot. Settling time, if you take this one, small changes lah. Okay, the steady state error, it will decrease, but you cannot get it zero. When you combine between KP and KD, so this is what you do. KP, maybe you can fit it to 300, 300, 300 for KP, and you adjust the KD 1, 10, 100, and 200. You will see that the KD, it will decrease your overshoot. Okay? As we know before, when we adjust the KP, we will see that the overshoot will be increased. But when you have the KD, you combine with KD, you will see that you will minimize the overshoot. However, there is no changes in terms of steady state error. You will see that, this one steady state error, almost no changes. Okay, all right. But you can eliminate the overshoot, right? And the rise time, it will affect also a little bit about the rise time. Okay, the settling time is also decreased a little bit. Okay, settling time, because like this one, the settling time maybe at this point. When you put it KD, settling time will be decreased a little bit. Okay, and when you combine between KP and KI, right? You fix the KP and then you adjust the KI, right? You will see that the KI, it will increase a little bit about the overshoot. But the good thing is the steady state error can be eliminated. So that's why an engineer, they like to combine it between integral or KI. Because we want to eliminate the steady state error, right? For example, you set your temperature is 20 degree. We want to get the temperature is 20 degree, right? We don't want to get the temperature at 22 degree, 23 degree. Right? So we can use the integral. So this is the function of the integral. Okay, and when we combine all things P, I, and D, of course, we can eliminate the overshoot, all right, and then you can get the steady state error almost zero. Okay, actually the zero, right? Okay, zero. We can increase the rise time and settling time. Okay, right. So far, do you understand it about the purpose of what we call it, the P, I, and D? Dah faham tak? Boleh faham tak? Okay. Ini saya pilih ni. WhatsApp group. Okay. Hai, boleh faham tak? Sekejap ya.
Boleh, Doktor.
Okay. That is the purpose lah of P, I, and D. Boleh lah sir. Oh, boleh sikit-sikit Okay lah. Alright. Okay. In speaker 6.1, okay. I think this one we can go through lah, because we want to focus on our revision, right, for the root locus. So this one we can look at into that. I think this one is simple. So you got it, this kind of system, okay, and then you want to adjust the GC. Okay, let's say you only use KP. You put a GC equal to 2, right? So that means this one is 2, and then for the T equal to 1 here. So what you got is this kind of equation, blah 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 blah. You do some fraction, and then you got this equation. Okay, and then let's say you combine. You use a KP and KI. Your KI is 2 over S, right? So I think you can see the difference, right? This one is KP, right? And then this one is KP and KI. Ki, that's mean Ki over S, right? So this one is Ki is 2 over S. So and then you do this one, I think you already know about this. So you got this kind of equation. And when you plot it, right, the blue color one is only you put it at Kp. And then the red color one is when you put it Kp, you plus it Ki. Right? So you will see that it will eliminate the steady state error. So the step input is 1. Okay. And then when you apply the Ki, eliminate the steady state error. Okay. Right? Is it clear? Boleh? Alright. Okay. Alright. Boleh any question? Any question that you want to ask? Ada persoalan? Tak ada lagi kan? Setakat ni clear? Okay. Boleh? No? Any question? No. No? Okay. No question yet, sir. Alright. Not question yet. No question yet. Okay. Alright. So let's look another chapter. Okay, this is what we're going to focus lah for your test 2. Okay. Generally, the controller is designed. Okay, never mind this one. Okay. Let's look example 6.1. Okay, this when you apply the P controller. Okay, for control system shown below, design P controller such that the damping ratio is 0.707. So in this case, okay. In this case, you want to design a controller, right? Okay, 6.1. So design the P controller, right? So you want to design the P controller so that it can fulfill the damping ratio 0.707. Okay. So the first thing is in this plot diagram, we know this is Kp. Okay. So first thing, GC S is equal to Kp. So our objective is what is the value of Kp so that the damping ratio equal to 0.707. Okay, alright. And then number 2, alright, you need to compute the open loop transfer function. So remember the root locus, the first thing that you need to do is to find the open loop transfer function. So how to find the open loop transfer function? The formula is KGH, right? So you need to look, this one is K, this one is G, and this one is H. Okay, so KGH right now is equal to Kp time with 1, S plus 1, S plus 2, then you time with your H now is 1, right? So you don't have H now. Then this one is equal to Kp over S plus 1 and S plus 2. Right? This is your KGH. Right? Okay. So for the root locus question, so normally Kp, it will give it to you lah. Right? So you just draw the root locus and so on. Okay. Alright. Now, step number 3. So now we do some root locus. So let's say this one is 1, right? Kp times 1. So we want to find what is the value of Kp. Okay. So first one, now you need to locate the zeros and pole. I think this is the step for the root locus that you need to be expert right now. So zeros, look at the zeros. So you don't have any zeros here, right? 0. Sorry, don't put 0. Put it none. Okay. Because if you put a 0, it's like S. Right? S plus 0. Okay. So put in none. Who is that? Kusai Jairodi. Wow. Okay. and then the poles, pole that's mean is -1, s plus 1 equal to 0 minus 1, and s plus 2 equal to 0 is -2. Okay, done. So how many of z is 0 and how many of p is 2? Okay, okay. This is the step of the root locus right now. 2, 3, 4. Okay, right? All right. Can you get it? Boleh, eh? Okay. So the next step for the root locus, so you need to plot them using a symbol x and 0. So let's say this is mine. Okay. Actually, during the test too, right? If you can draw it by using the normal graph, I think it should be good. Okay. So if you want to draw it in your answer script, yeah, it also can, because but however you need to show the value lah, okay, in your graph. Okay. Uh, let's say I put it here is what is that 0 minus 2. Okay, so maybe I put it here -1 -2 1 and 2 0 -1 -2. Oh, I expand a little bit. 0.5 -1 -1.5 -2. Tak cukup kan? Maybe 0.5. Yeah. Sorry guys. Take some time a little bit. 0.5 1 1.5 2. Okay, -0.5 1 -1.5. Okay, done. Then this unit is EMG, imaginary. This one is real. Okay. So far so good. Okay. Boleh? Right. Boleh?
Okay, Doctor.
Okay. Good thing. Right. Then there's this one, the step number 4. And then dah habis marker ni, tak cukup. Okay, number 4. Okay, number 4. And then you plot it in this graph. So pole is -1. Here, pole that's mean cross. Okay. And also -2 here. Done. Then you don't have any 0. Okay. Right. Then the second step, you draw the locus on the real axis. So this is your real axis. Then you draw the root locus. So this one, the root locus number first, and then this one, the second, right? The root 1 and second. So for the pole, the first one, it will go to the left, right? This one, right? Okay. So remember, right? So when you have it, this pole, right, and this 0, remember. Okay. So this one, this 0, try to find this one. This 0 going to this direction. So in this one, you need to remember it back. Okay. Boleh. Okay. Let me show you again. Chapter 4, the root locus. The root locus. You need to remember the. Okay, where is it? Oh, not this one. Yeah. This is the root locus procedure. Okay. So you can see the 2 pole, right, to be here. So this one, the first one. So it will go to the left. Okay. And this one, right, to go to left. Okay. And you have, if you see that this one is the pole and this one 0, so poles try to find the 0. So you need to draw the on the real axis first, and then this one try to find another girlfriend here. Okay. Boleh. Okay. Try to look at back. Alright. So we have draw this one. Done. and then determine the number of asymptote. Okay. Okay. Okay, the number of asymptote. Number 6. So number 5, we have draw the root locus on the real exit. Number of asymptote is P minus Z. The number of pole and minus 0, you got it 2. And step number 7, so you determine the number of asymptote. P equal to 2R plus 1 times 180. You divided with P minus Z here. So it depending on your R value. So because your R is 2, it will start from 0 and 1. Okay. Then you can find your P here. P here is equal to 2 times 0 and 180 and so on. You got it 90 degree and 270 degree. Right. Then number 8, so you determine the number of asymptote centroid. Okay, which is the sigma A is the summation of pole minus summation of 0 divided with number of asymptote. Okay, and this one, the pole, that's mean you need to summation it. So we got it pole minus 1 plus with minus 2. So this one is minus 2. And then we minus with 0, you don't have 0. And then you divide it with 2 minus 0. Okay, P minus 6. So you got it is minus 1.5. Okay, then number 9. So you need to draw the asymptote. Okay, coming back here. Draw the asymptote. So your asymptote right now, we look at it at this one, 1.5. Okay, so asymptote angle is 90 degree and 270. Okay, this is your asymptote, 90 degree, first one, and 270, this one. Okay, this is the asymptote 1 and asymptote 2. Okay, all right. Calculate the breakaway is exists. Okay, number 10, you need to calculate the breakaway. So if you look at this one, pole and pole, of course it will have the breakaway. Okay, the breakaway is we're going to this, right? We're going to this, and then it will break, right? Break away this one and this one. Okay, so we need to find the breakaway point here. So which point that it will break? Okay, right. So in order to find the breakaway, then you need to use the characteristic equation. Okay, characteristic equation. So in order to find the breakaway, dk over ds is equal to 0. So this is the characteristic equation. 1 plus kgh is equal to 0. Right, and then you do the 1 plus, like here we got it kb for s plus 1, s plus 2 equal to 0. Okay, and then kp right here, when you solve it, then you can get it here. Kp equal to minus s squared plus 3s plus 2 here. Then you will find that dk over ds is equal to minus 2 s plus 3. So dk over ds equal to 0. So minus 2s plus 3. Then you got it is s equal to 0.5. Alright. And also remember, this one is quite simple lah. So you can solve it by using this one. And you need to remember the formula v du. Is it this one? Yeah, v du over ds dt. I also don't remember dv over dt over p squared. Still remember this formula kan? Kena ingat jugalah. You need to remember. Okay. Alright. So maybe in order to solve it, you need this formula. Okay. Alright, so far so good. Okay, boleh? No question If you have any question, you can ask. Right? Now we got it for the breakaway is also at 1.5. Okay, and the next step is the next step. So that means your root locus it will go up almost it will touch the asymptote, right? And then this one it will go down. Okay. All right. And you it doesn't matter if you draw this one go up first or this one go down first. It doesn't matter because the both will be symmetrical, right? The both will be symmetrical. Okay. Right. Step 11. So you need to find the intersection into the imaginary axis. So it depending on your asymptote. If your asymptote is just straight line, right? This one 90 degree, that means you don't have any intersection to this imaginary axis. Your root locus try to follow the asymptote. Okay. If your asymptote is like this one, right? 60 degree, so you will have a chance that your root locus will go to this we cross the imaginary axis. Okay, so right now we don't have any intersection to the imaginary axis. Right? Then of course you complete your drawing there, right? And in order to find the value of KP here, so we need to fulfill what we want before. So for what we call it, the uh, damping ratio equal to 0.707. Right, so I mean you need to draw across this line, right? Then you can get KP here. Right. Right. So far okay? Faham ya? Ada apa soalan? Senang saja saya rasa root locus ni. Root locus, the first question is 13 mark. Okay. The second question is about your frequency analysis. Okay. Boleh? Siti? Siti okay? Tenas okay? Okay. Alright. Now we want to fulfill our objective. If we want to find the value of Kp in order to fulfill the damping ratio equal to 0.70. So as we know that the damping ratio will give you the beta here. Okay, so we need to find the beta from here. So damping ratio equal to cos beta. Okay, remember back this one on the root locus interpretation of the root locus. So we can get it the beta. This one equal to 0.70 cos beta. Then we can get the beta is about 45 degrees. Okay. So now back to here. That means you need to draw 45 degree from this one 45 degree. Okay. Draw it. Right. Then you will get it this kind of graph. Okay. All right. This part, right, for your test 2, I think it will not be asked, right? It will not be asked. You will do until you will draw the root locus, right? For this part, only we will ask for the exam. I hope so, right? I hope so. Because what I mentioned before, for the topic of integrate, interpretation of the root locus. So some other lecturer they like to teach that topic on the last topic, like this one lah. Yeah, chapter 6. Okay. Boleh faham Okay. Do you get what I mentioned it before? Boleh? Okay, good. So I just show this one, 45 degree. Alright. Then you will got it this point. Okay. So that's why for the chapter 6, you need to draw on the normal graph so that we can get it what is the value is about. Okay. So at this point you got it, the value is s equal to minus 1.5 plus 1.5 j. Okay. Imaginary is your j lah. Alright, yeah. Right. Okay, and then our objective is still there. We want to find the value of Kp, right? So how to find the value of Kp? So you need to what we call it to choose your roots here. So you need to connect it to all root here. Okay, you need to connect it all root here. Then you can find the degree here and so on. But we don't want to do that. That one is quite difficult. So you do the shortcut one. So what is the shortcut one? Is 14 here. Right. In order to find the Kp, our objective is to find the Kp. So kgh equal to 1. So where we get this formula, from the characteristic equation, 1 plus kgh equal to 0. Right? And then kgh equal to minus 1. And then we want only the magnitude. So kgh equal to 1. Right? So that's what we got it. Alright, done. Okay. So okay. So we are given your Kp, right? So your kgh now is equal to Kp divided with s plus 1 and s plus 2 here. Alright. Okay. So in order to find equal to 1, in order to find the Kp, so what you need to use, your calculator. The value for s, right, is your we got it the s from the graph. We got it here is minus 1.5 plus 1.5k, right? So this one will be your I put it here, your a, okay, your a here, okay. What you need to do, a you minus with minus 1, okay, and a minus with minus 2. Actually a plus 1 lah, okay, a plus 1 pun boleh lah, okay, a plus 1, right? This one is equal to 1. So you got it here, a is equal to minus 1.5 plus 1.5, okay. Then you can find your Kp exactly from the calculator. Alright, so in order to find the Ka, so you put it here, minus 1.5 plus 1.5i. Oh, I think you know about how to use the calculator, kan? Boleh, Ada yang tak tahu lagi ke? Macam mana nak adjust ni? Macam mana nak adjustkan zoomkan dia ni? Full mode, reset. Okay. Alamak. Okay. Zoom, mana nak zoom dah ni? Okay, zoom. Okay. First one, you set it, go to setup, go to mode, and you choose the complex, and also shift setup. You go to again, you go to 3 complex. So we want to choose the magnitude and also the phase. If it is just to done. So now our a equal to minus 5 minus 1.5 plus 1.5 I. Then we can save it. How to save it? I forgot it. Okay, alpha a. Oh no. Alpha a. No. Just press it equal. Okay, and then alpha a equal answer equal. This one, right? Betul Saya pun dah lupa dah ni. Okay. For this case, we can choose number 3. We just choose number 1, a plus bi. Will be easier. So alpha a, 1.5 plus 1.5i. Okay. So this one, that's mean a plus 1 times a plus 2. You need to time by 1. So now you got it. A alpha a plus 1 2 times with alpha A plus 2. Okay. Oh yeah, where is A? Okay. Hmm. Okay. Alpha A plus 1 times alpha A plus 2. We got it here. 2.5. How to see the magnitude? Saya dah lupa dah. Okay. Guys, how to see the magnitude? Do you remember? That's why we need to change to this, I think. Complex and 2. Yeah, 2.5. Yeah. Okay. So you got it the magnitude of 2.5, and then this is the phase angle, right? It doesn't matter, we don't want to look the phase angle, so we just take it the magnitude is 2.5. Right? So the answer is 2.5. Okay. Kenan, boleh? Okay. Okay. Boleh kan? When you use the calculator. Okay. Any answer? Malah nak tanya any question. Any answer? No. No. Alright. Good. Okay. Coming back to here. Alright. So you can find by using the manual method, right? But it's quite difficult. You need to find this length and this length and time. So just straight away use the calculator. I don't know. Other section they will teach this method or using that calculator. Yep. All right. And coming back to here, so we have achieved our objective. The first objective is we want to get the value of Kp where your damping ratio equal to 0.707. So we found that the Kp that we get it is equal to 2.5. Okay. That means your Kp like here is 2.5. Okay. Done. Alright. So you also can find another things about this one. You also can find the time constant. So time constant equal to 1 over damping ratio times omega n. So from this one, you also can find omega d and so on. So this is the value that you can get it for the roots 1 minus 1.5 plus 1.5j. Okay. And something else, what is it? Example 6.1 done. Okay, if you look at the time constant equal to 0.67. Okay, this is only you adjust the Kp, right? How about you try to adjust Kp? Okay, the second one is the other method. If you don't want to use the root locus, so you can use the second order equation like this one lah. You just compare, and then you will got it the same value lah. You will got it the same value. Okay, if we got the same root, then you can get the Kp. Okay. Alright, example 6.2, where you only use the integral, where you only use the I. Okay, so how to implement the I? So you just put it Ki over S here, Ki over S. So now your KGH right now, it will be different lah. Ki, S, S plus 1, S plus 2. And the objective is same. We want to get the value of Ki where the damping ratio equal to 0.707. Okay, then you do the root locus again, blah, 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 blah. Do again, do again. All right. And then you got it, the breakaway, you do again, okay? And then, yeah, you need to do, in order to find the intersection, okay? If we look at here, this is your roots. That means 0, -1, and -2, okay? So now, the real axis, the root local will be like this one, okay? And then it will have some breakaway, okay? And I think the asymptote right now is go to 60 degree, okay? The asymptote go to 60 degree, yep, 60 degree, 180 and 300. So that's why your root local going to this and it will cross your imaginary axis. So in order to find the intersection, then you need to use the root table. I think this one you know already, right? So in order to find the root table, so just need to put it 1 and then you skip. Okay, 1, 2. Okay, that's why 1, 2 and others is 0. And the other one is 3 and skip 2. Okay, 3 and K, right? It's okay. Okay, I like this one. Then you need to time lah. So 3 times 2 divide 3 times 2 minus 1 times K divided with 3. Okay, then you got it this one. Alright, and this one will be 0 lah. 3 times 0 time minus with 1 times 0, 0, 0. And this one K, so K, what is it? This one times this one minus this one minus times this one, right? 0. So that's why you got it on the K. So we can find the K from here, and we got it is K equal to 6, right? And then we can get it the two value, right? So this one will be your imaginary axis. So this one your imaginary axis. So for your root locus until here, that means you need to draw depending on the question. So the if your root locus cross to the imaginary axis, so you need to find this value. Alright, so in your graph, so you need to state that value lah. Awak kena tulis lah value tu. Right? If you draw it on the normal paper lah. If you draw on normal graph, it will be better. Okay, but the mark will be no different lah, as long that you can show the value. Okay, alright. And then we try to find the KI. So we just cross the length, the line from here or 45 degree, and then we got it. Yeah, you see that we got the value 0.382 plus 0.382. Okay, we got this value, and then you use that value, right? Right, use that value to get the KI, right? And then we found that we get the KI equal to 0.65. And we can get another what we call it, another parameter like time constant here and so on, and we can compare. All right, we can compare the value that we got it at before. Okay, so this one we only implement P, and this one we only implement I. So what the difference? You will see that, yeah, P controller, the time constant is 0.67. However, the I controller, the time constant is 2.62. So remember that, remember back on the first order system about the time constant. So the lowest time constant, so that means will be a fast response. Alright. So in this case, when you use the P controller, that means your system will be faster than I controller. Okay, that is what you can interpret from this value. Okay, boleh? Boleh nampak tak? Okay. Although that we only concentrate on damping ratio 0.707. Okay. Remember the damping ratio. The damping ratio is between the value from the. It depends if you have the damper, right? and the spring. So damping ratio equal to C over K, right? I don't remember that. Okay. So that's why the damping ratio is also quite important when you design the controller. Okay, any question? Apa soalan? Is it clear? Any question? Can you see the difference? Okay, boleh. Okay, can you see the difference? P and I. Okay. So what the information that we can get in here, we can get the time constant and we can compare. Okay. So this
Sir,
time, yes.
one question. To clarify, if he if the question tells us that there's the root locus will eventually cross the imaginary axis, then
Yes.
then we have to find the point of intersection using the Ruth table.
Yeah, correctly. You need to find that cross section. You need to find the point that cross to the imaginary axis using the root table, like this one. Okay.
And how do we exactly know whether like the locus will eventually cross the imaginary axis? How do we exactly know?
Oh, that's mean that's mean is that question okay. It is like this. Is it okay? Like this. Okay. The question is already show you. Okay. This is the root locus, and it give you this value only. Is it? Macam tu. Is it? And then from this, it asks you what is the what is the what you call it, the equation? Is it from here? Macam tu. Is it? What is this equation from this one?
Not exactly, sir.
Not exactly. Okay. I try to understand your question. Can you repeat back? What is it?
So my question is, in which case do we have to find the point of intersection? Is it when like the root locus? Yeah. Given.
So that means in which case that you need to find this value, is it?
Yes.
Is it?
Yeah.
Okay. It is depending on your root locus exactly. So if you have this two pole, and also you have a pole here. Okay, we know that this root locus on the real axis first, it will be like this. Okay, and then it will be like this. Okay, correct. Okay, and then this one you will know that there will be some breakaway, right? However, your line for the breakaway, it depending on your asymptote. Okay.
Okay.
So your asymptote right now you need to find. Okay, if your asymptote like this, okay, that's mean
it will cross the axis.
Yeah, it will cross to the imaginary axis. So that's mean it will go this, then it will go this.
Okay.
Okay, we go this.
Okay, I see.
So then you need to find this one, and then you need to use the root table.
Root table. Okay. Yeah, okay. Understood now. All right, thank you.
Okay, welcome. Okay. Then what else? Okay. So we leave this one on the next class lah. Okay. However, I'm going to show to you this one when you combine P and I. Never mind, we will repeat it again. This one. Please remember this one, right? Okay. Maybe you need to use this formula. Remember this one. Why you need to use this formula? So this one will be your V. This one will be your U, and this one will be your V. Okay. So you need to use this formula in order to find the K value, right? So this one look quite long. This one. So we see that the imaginary axis, right? So this one, this one, the breakaway point, sorry, for dk over ds is breakaway. So you need to find which one will be a logical value. So depending on your drawing lah. So that's mean in this one, the breakaway should be minus 1.5. Okay, right here. It cannot be 0.37 and plus 0.43. Cannot be. The breakaway cannot be something like at this point cannot be. So it need to be on the real axis. So this one the value will be logic. Okay. Remember this formula if that question asks you. Okay. Right. So far, do you have any question? Anything? Any question? Are there? Okay. So I think we are done for the root locus. Do you have any class after this? Ada class tak? Guys, do you have any class after this? Now already at 4. Ada kelas tak? Tak ada kan? Ahmed Mahmud, on what time is the tester? At night, right? 9 p.m. For your instrumentation tomorrow at morning, right? Okay, at morning. Pukul 5 ada kelas. Okay, alright, good. So I think can we proceed for the next topic for our revision. So this one we will stop at here and then we will continue. Boleh kejap saja. For your stability, I think you need to know how to use the root table. I think you need to know how to use the table. Yep, how to use it. Okay, this one. So stability, that's mean any changes of your sign. Okay, so if you don't see any changes, that means your system is stable. Then you need to use the roots, what we call it, the root table. Okay. If there is changes, right? For example, plus to minus, so that means it will show that your system is not stable. Okay, this one I think is quite clear. And you can find the value of K from the stability, right? Like here, you can find it the value of K. And you can assume lah, that's mean K, right? For this one, this one, right? So we already got it positive, and in order to make your system is stable, so that means this one should be equal to positive also, right? So that means it should be equal to 0 or less. That means more than 0. Okay. Then you can get the value of K here. Okay. I think it's quite simple lah, stability. So the concept is you need to find using the root locus. So find the sign, right? If the sign changes, so that means you can tell that your system is not stable. The root locus, we have covered it, all right? So there are many types, there are procedure to do that. Okay. So you need to remember all the procedure. Okay. So this one, I have shown you clearly, I think, in this lectures now. Okay, and then step number 5, we go straight away for block diagram series 5.1. So in this case, you need to do also the step. Okay, do also the step. Let's look another one. Okay, this example lah. Okay, so first you need to find the KGH. Right, so you already find the K here is 1, G here, and H is 1. So you found that this question, and then you can find the what we call it, the magnitude and also the phase angle. Okay, this step you can do it by you replace S with the JW, S equal to JW, and then you got it this one. And then in order to find the magnitude, that's mean square root 10 power of 2. And then this one need to be W, only W, square root. And this one, 1 square root plus 0.1, square root, square, right? Square and square root. This one, 1 square plus 0.1 W square. Okay, then you got this one. Okay, and then you find the phase shift, right? Is only look at W, right, over 0, okay, J over real, and 0.1 over 1, right? And so on. Okay, because of 1 over, so that means it will be all is minus, minus, minus. Then you can get it this formula. Okay, and then you going to plot on the Nyquist diagram on the polar plot. So like I mentioned you before, you need to you can use your calculator. You can get it straight away. But remember, we can find the omega means from 1 over T max. Okay, and we also can find the omega max 1 over T min. So T min, that means if we look into your what you call it, equation. So for example, you got a KTH here, 10 divided S, so 1 plus 0.1 S, 1 plus 0.1 S. Right. Bear in your mind, so yeah, so this one you need to be make sure this one will be in your format 1 plus ds. Okay, right. So this one also 1 plus ds. So make sure that 1 plus something, then from this one you can determine lah. So which one is the mean, so which one is the max. All right, and then from this one you can get it your V mean and V max. So this one will be your guideline in order to choose the value. So you got it W. So I always write like this one, W, and then this is your gain, and then this is your P, right? And then this is your P real that you want to plot. Okay, right. So in this case, you got it. W is 10 here, right? And maybe you can choose the value. If you want to get it accurate, you can choose 5, 3, or 0. Okay, depending. Then you can choose 20, maybe 30. Okay, all right. And then you can start draw the Nyquist diagram. So how to get this value? So it is quite simple. KGH here is equal to 10. This one is what? This one is AI 1 plus 0.1 AI and 1 plus 0.1 AI. Okay, betul kan? I am right? Okay, betul ya? Alright, so where your AI, you replace it W lah. Your AI equal to W, so where your W is equal to 0, 3, 5, 10, 20. Okay, the same method that we can use by using the calculator, right? And then you get sometimes you will get a MAC error, right? Of course, the infinity cannot be appeared on your calculator, so you can choose 0.00001. Okay, and then you will know that you will got it infinity. Okay, this value 3.058. All right, 1.6, and so on. All right. Okay. Okay. Then for the pace angle, so you need to be careful. So sometimes your pace angle, you got it a positive, all right? Positive 60, for example. So that's why you need to 60 minus 360, right? So you got it minus 300. Okay, so that's why you will plot your what we call it, the phase angle, it depending on this one here. Okay, you will plot G and real here. Okay, but on your Nyquist diagram. Okay, and this one example what? Example 5.3. Clear tak? Is it clear Ada persoalan? Saya terlalu laju ke apa? Tak Okay, clear Okay. So when you want to plot, so your plot is depending on the value for gain, right? And then the plot value of your phase angle. So when you want to plot, so you find out the phase angle equal to what we call it 123 minus 123, so 0 minus 120, 0, 10, 20, 30, okay, 120, 120, so 123, okay, will be like that. So this one, the scale you need to divide lah, okay, depending on your value. So you will look at the maximum one is 3.05, so that's mean you can choose the scale value as at 3 here, okay, and then this one start at 0, so you need to put it 0 and then you need to find lah 3. So this one what? 1, 2, 3, 4, 5, 6, 7, 8. So 3 divided by 8. So this one we start at 0.375, 0.75 and so on lah. Okay. So you need to be careful with this. So in order to find the step where you can get the step from here is how many blocks from here, so you can minus with the value before. Okay. So for example, this one the gain is 1.6. So 1.6 is located at this one. So 1.6 minus 1.5 divided with 0.375 divided with 10, because all scale is have 10 boxes here, right? So then you can get a 3 step. So that's mean from 1.5 you count lah, 1, 2 and 3. Okay, 3, then you bring out, okay, here is depending on your phase angle minus 143, yeah, and here, right? And then you start to draw your Nyquist diagram here. Okay, that is the concept. And then from the Nyquist diagram, you also can find the gain margin, right? In order to find the gain margin, you need to find the X value first. So X value, that's mean the value, right, for minus 180 here. Okay, so you need to find value from here to here. All right. So for the exam, you need to use the semi-log graph, right? I already give it to you, right? Semi-log graph. Semi-log pula. Polar plot graph. Polar plot. Okay. This is the polar plot graph. Don't forget to use this graph, okay? And print it. And print banyak sikit lah. Alright. Draw this graph. Okay. So the next graph. And then you, from here you can find the value of X. Okay, where are we? The value of X here, right? You can get it from here. So for example, 0.525, then you can find the gain margin 1 over 0.525 here. Okay, and then you will get the gain margin, right? And the phase angle, the definition is here. Yeah, definition is here. So you need to find the gain for one. Gain for one maybe like here. Okay, 1. Okay, So you bring it, yeah, this became for 1, yep, this one, and then you cross it, this one, you cross this line, then you record it, yeah, this value. So the alpha is between 180 to this value. So this one, the alpha, 180 until 155. Then you record it, yeah, this is the alpha, right? 180 until you cross it. Okay, okay, this is the alpha. Then you can get your alpha from the graph. Okay, right? So you got it alpha equal to 2.2, 22. For the x, you got it 0.5, right? Okay, there are two ways how to get the gain margin. Right? First one is from the graph, and then the second one by mathematically. Right? So mathematically, the gain margin, of course, equal to 1 over x, and you need to use this formula. So how to use this formula? So put it minus 180 degree to the phase shift formula. So you got it, this one phase shift formula before. Then you put the value of minus 180 to this formula, and then you can find the omega, and then after you settle this one, then you apply the omega to formula kgh. So the formula, the kgh that we got it before, this one, you apply the omega, and then you can get the value of x. Okay, and for the gain margin is 1 over x. So this value should be same with this value that you got it from the graph. Okay, you can find this one. And the last one, the last one for the page, for the alpha, if you want to find by using it mathematically, so 100 plus P this one, right, phase angle. So where the phase angle give you this formula, the same concept, apply 1 to kgh, right, equation, right, the first one you need to do, okay, this one, kgh. So this is the value for kgh equal to 1. And then after that, you need to find the omega. So you got it, the omega, right? So choose the logical one, right? Omega need to be 0 until infinity, okay? Cannot be negative. So you just get it, this value. After you settle, got it, this one, and then you need to settle this one, this formula, where you apply the W or omega to the formula of phase shift. So you apply it, this one, the formula of phase shift, you apply omega. This one, apply, and then you got it, this one. So alpha equal to 100 plus P, right? Then you got it, and you got it, this one, alpha. So alpha, the value for alpha normally will be small, okay? So this value will be same with the value that you got it from here. Okay, all right. Sometime, right? Sometimes the question, it will be help you enough. So sometimes you will see that, yeah, minus 180, the value is 0.5. Okay, so this is the x value, right? Okay, right? Okay. Uh, uh, Last semester, yeah, you can get straight away x equal to 0.5. Right? Like the example. Okay. Okay, so far okay, boleh? I don't go through lah into detail how to draw and so on. I think you need to do some revision lah. Okay, so if the question asks you to prove by using mathematically, I think you can refer back to. All right. Okay. Any question? Any question that you want to ask? Any question? Ada persoalan? Hi, Jen Kuat now. You are here not now. Okay. No? Okay, good. I think that's it for our class for today. For revision lah, alright. Okay. So try to look back the lectures note that I give it to you. I look back, right? So the step I already show you all the standard. Okay. I wish you good luck for the test 2, right? On Sunday at night, right? Start at 9 p.m. I think, right? Anything I will update through the WhatsApp, and you can ask me any question that you want to ask, right? And also good luck for tomorrow test 1 on morning, right? Test 1 on morning for test 2 for instrumentation, right? On morning at 9 a.m. Okay. Right, so that's it for our class for today. Right, so Assalamualaikum and good.
Okay, Doctor.
Okay, welcome.